This is a lecture on the topic of neural networks for classification using the Titanic dataset. Starting with our code, those lines of code are important necessary libraries for data manipulation, model building, data splitting and standardization from scikit-learn. Right over here, what are we doing is, we are kind of reading the Titanic dataset from the CSV file titanic.csv and we are storing it in data frame called df. It then prints the shape, as you can see over here, of the data frame using df.shape and displays the first few rows of the data frame using df.head. As you can look over here, you can see the shape and few rows and columns which are printed using df.head. Moving on to our next line of code. So what's happening over here is this code removes rows with missing values in the columns survived, ticket class, age, sibling, spouse aboard, parent child aboard, and fare from the data frame df using drop NA function. After this operation, the data frame df is updated to exclude the rows with missing values, and its shape is displayed again to show the number of rows and columns. In our next line of code right over here, this line of code groups the dataset by the ticket class column, and it will then calculate all the numeric columns for each ticket class with the use of .sum function right over here. Later on, what we'll try to do is, we'll try to create some dummies. In this column of code, dummy variables are created for the categorical columns ticket class and gender using one hot encoding .getDummies function. The drop first equals true argument is used to drop one dummy variable for each categorical column to avoid multicollinearity. Additionally, as we can see over here, columns ticket class 2, ticket class 3 and gender male are renamed to class 2, class 3 and male respectively using rename function for better readability. As we can see over here, class 2, class 3 and male. Let's see what happens next. Over here, the target variable survived is separated from the data frame df and assigned to the variable y. The features are extracted from the data frame df, which excludes the survived column and stored in the data frame x. Then the data frame is split into training testing sets using train.split method with 75% of the data used for training and 25% for testing. The random state equals 10 argument is used to ensure reproducibility. Next, we will try to understand a classifier named multilayer perceptron. So this multilayer perceptron is a type of artificial neural network used for supervised learning. So what we are trying to do over here is we have created a multilayer perceptron with maximum of 1000 iterations. The classifier is then trained on the training data X-train and Y-train using the fit method, as you can see over here. Later on, what we are trying to do over here is this line prints the default hyperparameters and their values for the MLP classifier using getParams method. So we can see activation, ReLU, alpha. So this is assigned value of 0.001. And then later on batch size, auto. So this is how the default hyperparameters and their values for the MLP classifier is printed over here. Moving on to our next line of code, what's happening over here is, after training the MLP classifier, predictions are made on the testing data X-test and using the predict method, and various classification evaluation metrics are printed including accuracy, confusion matrix, and classification report using functions from the matrix module. So we are trying to print accuracy score over here, confusion matrix over here, as we can see. What this does is it shows the number of true positive, false positive, true negative, and false negative predictions. And over here, classification report module is used. So what this classification report does is it prints a summary of the precision, recall F1 score, and support for each class in the test set. What we are trying to do over here is these are additional print statements which provide more detailed information about the classification performance, including accuracy, precision, recall, and F1 score. Now we will try to learn hyperparameter tuning with cross-validation. Right over here, we are trying to define a function named best that takes a single argument result. This function is designed to display the best hyperparameters and their corresponding mean test scores and standard deviations after performing cross-validation. This line over here prints the best hyperparameters found during cross-validation. The best params attribute of the result object contains the hyperparameters that resulted in the highest mean test scores. So this line of code extracts the mean test scores from the CV results attribute of the result object. CV results is a dictionary that stores various metrics and scores obtained during cross-validation. Later on, this line of code extracts the standard deviation of the test scores from the CV results attribute of the result object. And finally, what this loop is doing is that it is iterating over the mean test scores, standard deviations, and hyperparameter combinations obtained during cross-validation. The zip function is used to iterate more multiple lists simultaneously. And finally, the print statement is kind of printing mean test scores adjusted for the standard deviation and the corresponding hyperparameter combination for each iteration of the loop. So the format placeholders are filled with the values of m, s into 2, and p respectively in each iteration. Moving on to our next part of code. What's going on over here is this part performs hyperparameter tuning using grid search CV. So it defines a dictionary parameters containing different combinations of hyperparameter values, hidden layer sizes, activation functions, and learning rates to be tested. So the grid search CV class performs fivefold cross-validation to find the best combination of the hyperparameters that results in highest accuracy. So the function best over here is called to print the best hyperparameters and their mean test scores after cross-validation. So you can see over here the result of this code. And over here in this line of code, after the hyperparameter tuning, this line outputs the best MLP classifier model obtained from the cross-validation, which is one of the optimal hyperparameters. So in the next section of code, we will try to learn neural network regression using MLP regressor. So over here, these two lines of code, what they are doing is they are loading the house Boston dataset from the CSV file housing boston.csv and store it in data frame called df. The pd.read CSV function reads the CSV and creates a data frame from it. df.head is then used to display first few rows of data frame as we have seen before as well. Similarly, in the next line of code, what we are trying to do is we are trying to separate Um, so in this part, what's going on is we separate the target variable MEDV, which represents the median value of owner occupied homes from the rest of the features. So this line of code extracts the med_v column and stores it in the variable y. And in the next line of code, we are using drop function, which creates a new data frame x that contains all the features except the med_v column. This data frame x will be used to store the feature variables for regression. And right over here, what's going on is we are splitting the data into training and testing sets for the regression task using train test split function. The feature variables x and target variable y are split into two training and testing sets. By default, 75% of the data is used for training and 25% is used for testing. In this line of code, we are kind of creating an instance of an MLP regressor with maximum of 1000 iterations. So the MLP regressor is a neural network based model for regression tasks. The model is then trained on the trained training data, xtrain and ytrain, using fit method. And at last over here, in these lines, the trained neural network regressor model is used to make predictions on the testing data x test, and predicted values are stored in the variable pred. After making predictions, the mean squared error function from the matrix model is used to calculate the mean squared error between the predicted values and actual target values. The MSE is a commonly used metric to evaluate regression models, and it measures the average squared difference between predicted and actual values.